Hello, everybody. In this video, we're going to do a little bit of a discussion of how do we calculate out some of these values that we are interested in order to calculate out a confidence interval. Okay, so there's a couple of things here. We're going to be using both Jamovi and Excel today, and let's just kind of go through and take a peek at it. So when we get a problem, so let's say that we're interested in this problem. So it says you are interested in finding a 90% confidence interval for the mean number of visits for physical therapy patients. You are fairly certain the data is normally distributed. The data show below that the number of visits for 13 randomly selected physical therapy patients. Round the answer to 3 decimal places where possible. Okay, so we're going to do this like the really fast way inside of Jamovi, and then we're going to kind of walk it back a little bit and see exactly where does this all come from, and so we can kind of piece together the parts. So first of all, we'll just say, hey, we've got some data. It's normally distributed, and so we get to kind of use all of our normal distribution handiness. We get to invoke the central limit theorem, and we're just going to go ahead. I'm just going to highlight those data points. Now, I'm not going to highlight the label because that will kind of give me some problems. I'm just going to go ahead and copy that. I'm going to bring it over. We'll go to column A, and I'm just going to paste it in there. I'll double click on A. I'm going to change this back to like number of visits. Yeah, we'll leave it as just integer, and we'll just call this visits. Okay, great. So at this point, I'm going to go to exploration. I'm going to go to descriptives. I'm going to grab my visits over, and we get a bunch of things that we're interested in. We get our mean, which is our sample mean, x bar. We get a standard deviation. We get the sample size. If we remember that when we do a confidence interval, we also want the standard error, and we want the confidence interval for this mean. Now here it says we want a 90% confidence interval, so we're going to swap this out to be 90, and we can hit enter. Okay, so now what we can see, it's like, great, I have all the pieces of the puzzle. To do this distribution, we want to use a t distribution. Okay, so when we do our confidence intervals, we're going to use a t distribution because we don't know a population standard deviation. The only standard deviations that we know is from the sample. Cool. Okay, so now it's asking me, what is this confidence interval? And it says 13.58 to 19.95. And when we look at the answers, 13.58, 19.95. Jamovi gave it to us. Fabulous. So now it says if many groups of 13 randomly selected therapy patients are studied, then a different confidence interval would be produced from each group. So if I went and did another sample of 13 and I took the mean and I calculated out my confidence interval, it'd be a little bit different. It'd be close probably, but it would be in fact a little bit different. So what this is saying that if we were to do this a ton of times, let's say like a million times, about 90% of those confidence intervals will contain the true population mean number of visits per patient, and about 10 of those, about 10% of those will not. Okay, so we went through, we calculated out our confidence interval. Fabulous. Let's kind of dive in a little bit deeper to what this problem is actually asking us to do. Let me go ahead and grab let's do a new slide. Give me just a second. We'll delete these out. And let me kind of draw out for you exactly what we're doing. And in order to do this, let's kind of do a split screen here. We'll put this guy over here. We'll put this guy here. And let's make our, okay, that's about as big as we can get it. Okay, so if we draw kind of a normal distribution, and we'll say, hey, I have this normal distribution. And wow, that's a really, apologize about that. Let's see if I can get it a little bit more level. There we go. I am going to center on this distribution. I'm going to put X bar at the middle. I don't know what the true mean is, but I know that the sample mean is going to be equal to 16 point, I'll just do 16.8 right now to do some rounding. I need to scale this distribution. So remember, one standard error is reached at the inflection point. So I'm just going to draw this out real quick and draw it down. Okay, so I know that the standard error here is going to be equal to, we have the standard error of 1.78, or we'll just do 1.8, that'll help me out. 1.8. All right, so if I scale this thing, this is going to be at 15, and if I go 1.8 up this way, it's going to be like 18.6. All right, and then I could do another 2, and so this would be like 13.2. And if I go another, roughly like one standard, the distance on this distribution of where one standard error is. And if I go up another 1.2, that's going to be, if I add 2, be 16, or sorry, 20.4. Okay, so I've got kind of my distribution going on here. And I want to calculate out a 90% confidence interval, or like where is roughly 90% of the area shaded. Now, if I look to see where the answers are over here, you see the correct answer is 13.6 to 19.9. We see here, that's right about there as our lower cutoff, and our higher cutoff is 19.9. Sure, is kind of right here. And that is our confidence interval. So how do we calculate that out? So a confidence interval for, let's say, 90% confidence level is going to be equal to our x bar. So let's start off, we'll just write this out generally first. X bar plus or minus t crit times, oopsies, give me just a second, I'll erase that, times the standard error. Okay, we've got a lot of these pieces right now. We've got 16.8 plus or minus, I don't know what t crit is, and we'll say times the standard error, and we know the standard error is roughly 1.8. Okay, so we need to figure out what this t critical is really quick so that we can actually do this. All right, come along with me. There is, I think it's in distraction. So this is a module that I've added in. If you want to do this with me, you can. Let's go to modules. We'll go to Jamovi library. And if you go to the available, I think it's called distraction, D-I-S-T-R-A. Yeah, distraction, quantiles, probabilities of continuous and discrete distributions. If you install that one, it's going to allow us to play around with the t distribution. We know that we need a t distribution when we are doing our normal distribution. So let's go ahead and play with it. So if we're playing with a t distribution, we need a little bit of information. We need to know, okay, how many degrees of freedom? And you're like, yo, Ethan, what is a degree of freedom? Degrees of freedom are super, super easy to handle. All a degree of freedom is, if we go back up here, did we pull it out? Will it give it to us in here if we ask for it? Does not look like it. Okay, degrees of freedom are super easy to know. Let's just write it down real quick. So a degree of freedom is equal to the sample size minus 1. So in this case, our degree of freedom was just equal to 13 minus 1, so it's going to be equal to 12. All right, we can go back to Jamovi and play around a little bit. So in our t distribution, we're going to change our degree of freedom to 12. We're going to leave this guy alone, and we're going to say we're going to compute the quantiles. And we can do either the central quantiles or the cumulative. Nice thing about quantiles for the confidence interval is we want the central, and we want that middle area to cover, in this case, what was it? Was it 90? Let's go back and look up above. It was a 90% confidence. So we're going to go ask for the t distribution here to give us the quantiles for 90% of the central area. Okay, so if we want 90%, notice it's saying, oh, from 0, you need to go plus or minus this 1.78229. Okay, let's remember that. 1.78229, that is our t critical. Number of standard errors we need to go above and below to capture 90% of the area under the curve. Okay, so remember that. 1.78229. Let's go here. So our t crit is equal to 1.78229. So we should be able to get our values here that we calculated by doing this of 16.8 plus or minus 1.78229 times our standard error of roughly 1.8. Let's go back to Jamovi and check this out. So you can do this in Excel if you want. I'm going to use some of our other tools that we have in Jamovi because Jamovi has some really great calculator abilities in R. So I'm just going to go down to RJ Editor Plus. And in here, I am not going, well, okay, I'll show you how to do this. You could just type them in, but I'm going to take visits and I'm going to make it a variable for me. And I just want to show you when I calculate these things out that the editor here has a nice ability in order to calculate some things. So first things, I'm just going to say that X bar, or our sample mean, we had it up here, and I'll just type it this first time. We'll do 16.76923. I need to put a point there. 0.923. That's our X bar. We knew that the standard error, so I just said SE, is going to be equal to, we had the standard error is equal to 1.78725. And we have the T crit. We have to get that down here again. Where did you find it? Okay, 1.78229. Okay, so my lower bound is just going to be equal to X bar minus T crit times the standard error. And we'll show it by just typing lower. Nope, stop that. And then I want to do my upper is going to be, and I'll copy this exact same thing, and paste it, and do like a little plus symbol there, plus, and I can show my upper by just doing it like this. Now, if we click on the little gear icon, we can say show code and output, and I'm going to run it. And, oh, one other thing is in here. You have to tell it how many digits you need to show. If you do options, digits equals, I think 8 will give you enough. If you can play around with this number to get the number of decimal places that you want. I can't spell. There we go. Okay, so now I've got the decimal places that I want. So I said doing this manual calculation, it was 13.58 to 19.95. And up here, 13.58, 19.95. Okay, the one calculation that we kind of didn't talk about that we had talked about previously is the margin of error. And all the margin of error is equal to is that T crit times the standard error. And so your margin of error, if you want to see it, we can run that again, is this 3.185. So we're taking our X bar, which was 16.8, and we're doing plus or minus our margin of error, which we saw it as equal to 3.185. So that's how you kind of walk through and do this inside of Jamovi. And notice how we kind of did this calculation by if we had been given the sample statistics already. Sometimes they will just give you X bar. Sometimes they will just give you the standard error. Sometimes they will just give you the T critical. Sometimes they don't give you the standard error. Let's suppose that they just gave us the sample standard deviation. Could we get the standard error? And the answer is like, absolutely. The sample standard deviation was, we'll do 6.44404, and the sample size, n, was equal to 13. And so we can also calculate the standard error by saying s divided by the square root, sqrt, of n. And we can ask to see it again by just typing out se. We run it again, and notice how we get the standard error of 1.787, and that's what we got up here, 1.787. Like, look how handy that is, that we can do all of those calculations just right here inside of Jamovi.